All right, what I want to do here is I want to very quickly explain to everybody what a free radical is. It really is very simple, but it does require some basic knowledge of chemistry. Namely, you have to understand what an atom is. So if you look at the whiteboard, on your left-hand side, what we have here is a normal atom. And what you will see with a normal atom, let's see if I can move this. Oh, forget it. What you see with a normal atom is that the inside has a bunch of protons. These are generally a positive charge, and so you're going to have varying levels of positive charges within this center, various protons that is, and that kind of helps to classify what type of an atom this might be, whether it's carbon, or if it's oxygen, or if it's nitrogen, or boron, or any of those other types of atoms that are in the periodic table of elements. What you're going to see then is that there's a bunch of orbits, and in this case I have two orbits that I drew out here, and circling around the orbits are electrons. These usually have a negative charge. So you have positive on the inside and negative on the outside. And every atom has a different amount of positive charges on the inside and a different amount of negative charges on the outside. I think I said that backwards. Protons positive on the inside, electrons negative on the outside. Okay, so that's what we would consider a normal atom. What you also notice is that the electrons that are circling around the orbits are circling in pairs, and that is also perfectly normal for a normal functioning atom. When an atom is circling in this way, or when it has the paired electrons that are circling in the orbits and it goes about the body, it does its function. If it's carbon, it's going to do what carbon needs to do. If it's oxygen, it's going to do what oxygen needs to do. If it happens to be hydrogen or nitrogen or whatever else it might do, it will function as those things in this normal, stable state. If you look over to the right, though, this one is a little bit different. And what you're going to notice over here, it still has the protons, it still has electrons, but down on the bottom there is one electron that is missing a pair. This can happen sometimes when an atom gets damaged, and we will talk about later on in the module some ways, in fact you'll be talking about it as soon as we're done here, ways in which this thing does get damaged or loses another electron. And so what happens then is when that happens, when it loses its other pair, then suddenly this pair is lost and it goes crazy. It doesn't know what to do because it can't function without the other pair. We call this atom a damaged atom or a free radical. It becomes a free radical once the pair is gone and now its purpose changes. So if this was originally carbon or originally hydrogen or originally oxygen, it no longer will function as any of those things. Instead, it sees that it's missing a limb, if you will. And so what happens is it has only one purpose in life now, and that purpose is to go around and try to find or steal, what is usually what it does, another electron from a normal atom. When it does that, then it will satisfy the pair again, and then it can start functioning as it is supposed to function. The problem is that when it goes over to, say, a normal atom, look to the atom on your left again, if it were to take and pair or pull that one over, let's see if I can kind of show you guys how this might work. Let's do this. That's going the wrong way. Okay, flip it around. Go back to the drawing board. Oh my goodness. Okay, well, forget that. I'm going to spend all my time here trying to draw and mess up my drawing. Go ahead and let's just envision that what this thing does is this free radical bumps into the atom that is next door and it steals one of the electrons from this atom. What's going to happen once it ends up doing that is it's going to end up leaving that particular atom with a missing electron. Let's say it steals this one right here. So there we've just gotten rid of that particular atom, but now this normal atom, or it was a normal atom, becomes a free radical. So this process can continue. It becomes a chain reaction in which one free radical steals electrons from another perfectly good atom, which then becomes a free radical, which then steals from another one, which becomes a free radical. And sometimes in the process of these things bumping into each other and clashing and trying to steal electrons, electrons just get lost in the process. So as they get lost into outer space, even though you might have started out with only one free radical, you might end up, because of the damaging nature of these free radicals, you might end up with 5 free radicals. And so whenever you have one in the body, it starts attacking all kinds of other cells and it creates a bunch of other free radicals. So the point of this whole thing is to understand, first of all, what a free radical is. Namely, it's an atom that is missing an electron. It's really that simple. But you have to understand even more than that, it's not functioning as a typical atom now. Now it only has one function. That function is to be destructive. And as it becomes very destructive, it destroys other cells and other atoms in the area, which they then also become free radicals. So let's talk about then in the module as we go on, what's creating the free radicals and how you fix the free radicals, because that can be fixed through diet.